There we go. Hey everyone, and welcome to the July edition of the DefCon604 Meetup. Today we have another workshop with Dana Epp. Dana has spent decades as a security architect that focuses on helping secure software, data, and infrastructure. You might say he's been on and led blue and red teams well before it was even a thing. When he's not helping to build and grow software companies focused on developing security tools, he's advising others on how to build and break their own applications and environments. As both a Microsoft regional director and security MVP, he spends a great deal of time on security de-engineering in the cloud. Lately, he's challenged himself to be more on purple team, shifting more on his offensive tradecraft to help developers and IT administrators see demonstrable impact of exploitation of vulnerabilities in their work. He's a director of OWASP Vancouver and is #1 ranked Canadian hacker on Try Hack Me, where he teaches others how to hack apps and infrastructure. Their workshop is on Pwncat and developing custom attack modules. And with that, over to you, Dana.
Awesome. Thank you very much. Just before we get started, let's just make sure everyone kind of level sets. We're going to be doing a hands-on workshop. We're going to step through things together. For that to work, you're going to need to be logged in to a Try Hack Me account. So if you don't have one of those already, you're going to be a little slow to get going. Here is a link I'm putting in the chat right now to some of the resources. So as we're talking and walking through this, you don't have to read it verbatim. I'm going to talk you through some of this stuff, but we are going to get you to actually catch some reverse shells and bind shells and connect the SSH using Pwncat, which is really a C2 framework that allows you to do more with the shells that you can have. And I'm going to show you just some of the interesting things you can do with that, including how to write your own exploit modules so that when you're in an engagement, you can get the work done that you need to do. Because in many cases, you might have specific needs that you can automate, and why not? So just before I get started, we have you all muted, mostly because people like to Zoom bomb us at the beginning here. But I just want to get a kind of a sense. How many people here on a semi-regular basis actually have to catch a shell? Just say yes in the chat. So that's good. We're seeing some. How many who never ever catch shells? That's okay. What, that? Only it's part of exercises. Yeah. So it's okay if you haven't. The concept is also going to be the same with what we're doing. So Pwncat actually has the power to be useful in an SSH session. So if you connect remotely to a host using SSH, you can use Pwncat instead of the SSH client. And a lot of the stuff I'm going to show you here, you can do there as well. So sometimes it's not about attack tradecraft on having to exploit stuff. It could just very well be you're an IT guy that when connecting to SSH, there's a whole bunch of things that you need to do on a regular basis. Well, you could automate that stuff. If you have a little bit of Python skill, you can write your own modules to work stuff out. So you don't have to always be uploading stuff and executing stuff, etc. You can have it all run through the C2 framework that Pwncat is. Okay, so to kind of get us started, one of the first things we've got to do is make sure everyone is connected up via Try Hack Me. So if you haven't already, VPN in with your OVPN credentials and get logged in. And once you're logged in, I want you to also go to the Try Hack Me portal, and I want you to go look for a room called What the Shell. And I'll put that link in the window here too. Looks like that one's already been running, so I'm going to kill that session. All right, so once you're in this room, I want you to join the room just by clicking on the join button. It's on the top right. And then scroll down to task 14. the Linux practice box. Subscribers only? Really?
Hey, yeah, Dana, it tells me it's subscribers only as well.
Okay, hold on. Let's see if we can get another room for you then. You all should be subscribers. I guess that's the moral of the story, isn't it? No, I'm joking. I don't even remember how you tell if it's only subscriber only. This is a free room. All right. Let's see. Ah, damn. Sorry, guys, I didn't realize. I want to get a room for you that already has SSH so that you can just jump into it. Because we're not here to hack the room today. We're here to show you how to work with the shells. Let me just see. Is there anyone who hasn't connected up via the OVPN yet? Just want to verify. Damn. No shells for you. Yeah, thanks. You're stuck, Alexander? What are you stuck on? You have a try hack me. You have to download the VPN config. Yeah, so what should happen is when you're in your, if you have your try hack me account set up, you can go into access and there's a file there to download your OVPN. So while you're doing that, I'm just going to try to find a room that is for
We'll help out, Dana. You can focus on the room.
Yeah, just find any room that has SSH creds. While you guys are digging that one up, why don't I just kind of get started to show you some of the stuff, because we can get going and then we'll loop back with a different room once someone finds it. Thanks, Amaran, for doing that. So just to kind of get us started on how Pwncat works and what it does, what you want to do when you get started is when you start up one of these rooms, you're going to have, so I got to go back to the room I was in. So I'm going to use this one. So if you do have a VIP account, you can follow along with me. We'll get a room that's got free rooms here in a minute. So you're going to click Start Machine, and that should spin up for you. Linux Fundamentals Part 2. Is that got a does that got a SSH creds, or is that a attack box only? Perfect. Thanks, Kevin. Okay, so let's flip over. I'm just going to continue to use this Linux practice one, but you should be able to follow along with this Linux fundamentals one. And then if not, I'll jump in and we'll go back and see. All right. So when you first get going here, you're going to get an IP address and you're going to need to copy that. because you're going to need to use that to connect up. Or if you want to, you can put that into your host file. So, you know, something like I'm going to call mine just VM for no other reason because I can. Are you guys even seeing my screen?
Nope, just you.
It's probably not going to be so great. No one needs to see my ugly mug. All right. So do you see a bash window?
Yep.
Okay. So obviously, you should be able to just SSH into the target with the creds that it has in there, which is try hack me for shell practice. That works pretty easy, but you can use Pwncat to do the same thing. So if you do Pwncat and your normal login, you have the ability to do something similar, but it's going to act differently in what it's doing. So same prompting. But when it connects, you're going to see something that looks a little different. So you'll notice right off the get-go that it's saying local Pwncat. And what that is that Pwncat is a C2 framework that has a local mode and a remote mode. When you're in local mode, it uses a channel that's been connected up to establish and communicate with the other side. If you want to just get that shell, just like when you SSH in, you just hit Control-D, and that will switch the mode into remote mode. And you can see here, it now says remote. And then of course, in this case, the account I'm in and the path I'm in. Of course, that could differ based on what the bash prompt configuration is, but you always have either local or remote. And get back and forth, you just hit Control-D, right? So you can see, you can do this till you're blue in the face. All you're doing is jumping back and forth. It's important to know that because when we're executing commands in Pwncat, we execute them locally, and then they get sent to the remote host and executed. So that's important for us because that means when we write code or do any kind of work, we host.
Dana, sorry, can you make the font larger?
Sure. Is that better?
Maybe one more step.
Wow. All
Cool.
good?
Think so.
Okay. So hitting the Control-D to go back and forth gives us the ability to get to where we need to do work. So in our case here, maybe the first thing we do, it's a new host, we don't know anything about it. We want to do some recon. So if we want to, we can run a command, very similar to how Metasploit modules work. You would say, I want to run something. So in this case, we might want to say something like, we want to enumerate. And great thing about Pwncat is it has tab completion. So if you're not sure about some of the words or syntax, you can tab and it will give you what do you want to do. And so here's an example. You can see we can just call enumerate, or we could do specific things. There's a whole bunch of different modules here, and we'll talk about some of them as we're going. But just to get started, I'm going to call one called enumerate.gather. Okay. Now, as I'm running this, you'll start seeing it's actually executing code and gathering information, recon on the remote end and bringing it back to store locally. While that's going on, I just want to see, see if I can bring up the chat here. Who has been able to get connected to a session with Pwncat? Anybody?
For me, it's hanging right after asking me for a password and nothing happens, but maybe it's just me.
Hanging after password. Is this on the free box?
Yeah.
Okay. Okay, well, we'll keep going here on this right now. If we can't get you guys squared away, then we'll go take a look and see what's going on there. We can see what happened when I connected here is it did a whole bunch of collection, right? It took a look what kind of system there was, what files have been mounted, what is the network information for this host, what are some users. One of the terms that Pwncat uses is something called facts. This is facts or information or insights of the host. So in this case here, we can see the bunch of users that are in the system. We can see the kernel version. We can see what processor was used. We can see file caps here, so the MTR packets, and we can see groups. This is all pretty common stuff that you would normally do. So having the ability to have that execute for you and run is really nice because it allows you to collect all that information as soon as you connect up. It's actually possible to use a RC file so that on connection, you could automatically run this if this was something you always wanted to do. Don't recommend doing that, but if you wanted to, you could. Now, what's nice is you don't have to run the whole gather because that might take a lot of time. That might actually be touching a lot of things that you may not want to do. So you can always just run individual things. So let's say I just wanted to look for, let's say, suid files. I could just enumerate.file.suid and boom. Now you'll notice how fast it came back. Once the system has got that information, it's actually stored locally on a database. So you can immediately see that information. You can rerun it to collect it if you need to, but that stuff comes back pretty fast for you. The other thing that makes that very useful is that it then gives you the ability, because all that data is stored, that if you ever need to report on it, even after you've disconnected, there are capabilities to do that. So as an example, you could type run report output equals, I don't know, report.md. And if we go look in the other window here, we can see that we've created a markdown file with all that information. So as we continue to collect all the information and get stored, we can report on all of that stuff out. So we don't have to cut and paste everything. It's there if we need it, at least for that part of it. With me so far? Connected after delay. Okay.
Yeah, I'm not sure what it is. It almost looks like
delayed?
Some sort of DNS lookup sort of timeout or something like that, but it did connect, I think. Yeah, I'm pretty sure. Okay. It shows active session.
Can you hit Control D and see the actual shell?
Yep.
There you go. All right. Well, that's a good sign. So Alexander's asking, how do you start Pwncat? Well, after you got the IP address of your VM, once you started the VM, so I don't know if you noticed what they were going into this room here. I'm going to put this room in unless you actually have a VIP account. That's the other room. That's what people are using right now. If you start that room in task 2, there's a button to start machine. And you're going to want to start that machine so it'll spin up a VM. So how TryHackMe works is it has a private set of networks running in AWS. So anytime you start a machine, you're literally running an EC2 VM in a private network that gives you the capability through your OVPN to connect up to it. So you can have a private, cyber weapons lab to detonate stuff and have fun and not worry about causing a lot of problems, which is one of the benefits of a platform like TryHackMe or Hack the Box, or there's tons of them out there. Okay. So once you've got the VPN up and running, start that VM, and then once you got that working, you're going to run a command such as this. I'll just type it in the chat window. That account at IP is, I guess in this case for that room, I don't know what they called it. I think it was TryHackMe was the user. Yeah, TryHackMe, and then the IP will be whatever the machine IP is you get for that room. If you want to, you can also put that IP into your host file so that it's easier to look up. And you could use a command like this to do it. So what you see in there is obviously the x.x would be the IP that you get on your VM. Thanks, Amaran, for walking him through that. Okay, so getting back to Pwncat here. So we're able to connect up via SSH. We've got the Pwncat framework in place, which allows us to get on the system. But let's take a step back to talk about what happened when you connect it. When you throw a normal shell, so I'm going to actually just disconnect here. And I'm going to SSH in. And let's say that I was just over on my right side window, I was to start a Netcat Listener, right? So if you've used Netcat before, how you can catch a shell is using something called Netcat. And you can just go NC -LP. It means I'm listening on port. In this case, we're going to go 4444. So I'm now listening, waiting for a reverse shell to come in. So on my VM in TryHackMe, I could basically send a shell back. So I would do something similar. Actually, before I do that, I just need to figure out what IP they gave me. So I'm just going to send a bash shell back to me, okay? And here's what happens. It's connected. You have no idea that it's connected. You don't know unless you were to do something like type, who am I? Oh, ls -la. Oh, I can see there, but it's not a very stable shell, right? And so one of the things you normally do is stabilize a shell. Can anyone type in what they would do to stabilize a shell if they were catching a shell? Kevin's like the Python C stuff. Yeah, that's exactly what I would do. Or I would use QScript. What I'm basically doing here is I'm actually calling Python to import PTY, and I'm going to spawn a bash shell. And now I have a more usable shell. Problem is, it's still not a great shell, because if I wanted to do something like use up arrow keys, well, you'll see that doesn't work. And if I try to go back, or let's say I ran a command wrong and I hit Control C, oh, I just dropped my shell. And if you've done all that hard work to get a reverse shell, maybe you're trying to exploit a Java vulnerability that's going to call back to you, the last thing you want to do is lose your shell. And that's one of these problems that bad shells give you. So there are things you can do. There's a whole bunch of extra things to set the TTY and do all that stuff if you want to, but it's just a hassle because Pwncat will do all of that for you. So when I'm going and connecting up, it creates that session and does all that heavy lifting for you, right? Actually, this is a bad example. I don't want to show you it on the, I want to show you it on the catch side. So instead of doing the NC like we do here, Pwncat has the ability to catch it just as the same. Same thing, -LP. We're listening for that shell. And if I just jump back into and I throw that same bash shell like before, watch what happens. So you'll notice on the right side, I've got my C2 shell. And again, I can just Control D and I'm now at a full shell, just like before. But now I get the benefit of things like up arrow. And I can Control C and it won't kill the session. It gives me that flexibility, a more stable shell to be able to do work. And of course, I can still do things like, you know, I can go back into local mode. I can do run enumerate.gather, and I'm doing another gather. With me so far? Little interaction here, chat in the chat. Just yes, no, maybe so. What the hell are you talking about, Dana? They're with me. Some of them can't SSH in yet. All right, so this is my apologies for not having the right room for you guys. I didn't think about the fact that the basic shell practice was actually a VIP room. The NC on the free box doesn't allow. Oh, okay, cool. So if the NC doesn't allow you to work on there, use a different shell. So I don't know if you guys are aware of this, but if you've ever checked it out, there's some awesome shells you can have generated. If you go to revshells.com, buddy of mine, 0 Day, works on this. And it's kind of cool because you can get different kind of shells that might work better for you. So if the Netcat shell is not working for you, you can just as easily run a bash shell. So what you would do is you could take the IP address. What was that IP address that I had here? And let's say I'm going to use port 4242, and I could have a bash shell here, and you can decide what shell you want. In this case, I'm going to have a bin bash shell. So you can actually see it's generating for you the command you're going to use. You can even encode it. So if you're working on any kind of a platform play where you're working on some sort of exploitation where you might have to URL encode it or base64 encode it or whatnot, you can build different kinds of shells. And there's everything here from bash shells to NC make FIFO, which is probably going to work for you on that target. Pentest Monkey can do the same thing. This just automates it for you, kind of generates it for you. There's tons of different ones here. So, you know, PHP shells, Perl shells, C# shells, PowerShell shells, even Windows Con TY. And you can even use, it'll also generate MSF Venom payloads for you. So this is a nice website if you just want to generate a new shell on there. So if your -e is not working, try this one here. The NC make FIFO. I will bet you that one here will work for you. Just make sure you put your IP in and the port that you want to use. Okay? Bash -i work? Perfect. So there you go. So, all right. So back to here for me though. So I was able to use Pwncat to connect up to the, in this case, catch a reverse shell, right? Because we actually caught the shell that I had ran from NC there. And when I caught the shell, I was able to run those commands locally, and it actually ran them via the reverse shell. But maybe that's not enough. Maybe I want to do more, right? I'm a big fan of linps as an example. So one of the things you want to do is maybe upload linps to the target. Now, that's easy to do. You just set up like a Python web server, host it up, then you could just curl or wget it. But what if curl or wget's not on the target? Oh, now it's a little harder. Well, what if you don't have Bash or you don't have Python? Like, what if it's a Java only shell? Well, here's where Pwncat comes into its own. Because what it does is it uses GTFO bins to look for write primitives. And if it can find a way to do a write primitive, it will allow you to upload content. So that becomes very powerful because that means that we don't care how the remote host is set up. If there is a write primitive somewhere on the system, Pwncat will find it, and then that would allow us to do something like run a command like upload. So in my case, I'm going to say I happen to have linps in my tools directory in opt, and I'm going to go drop it in temp on the target. So without having to worry about setting up another server, this actually runs it through the C2 channel from that reverse shell. So there's no extra connections. There's no way to trip up the IDS sensors to seeing, you know, transfers happening with wget or curl, because it's happening over that reverse shell. And that makes things a little cleaner, a little nicer. And if I now go and go back into remote mode and I go into temp, we can see linps there. Now I'm just going to make it executable. And I'm just going to run linps here. I'm going to use the -s flag, which is the stealthier, faster method. You can use whatever you want to use as a command. And I'm just going to send this to a file called recon.txt. And so now this is going to run for a couple of minutes. And while it's running, I'm just going to go check back in the chat and see if we got some people here connecting up. Okay, let's see here. Just hangs. You can try. Yeah, so as Amaran said, if you're having issues there, just do a normal SSH into the box and then run the Pwncat in the listen mode, which is Pwncat CS -LP and then whatever port. And then you can then send yourself a reverse shell. If you can't SSH into that box, there could be something wrong with your open VPN connection. Yeah, can you ping the IP? The only reason I'm not telling you guys to go jump on the attack box is that Pwncat's not guaranteed to be installed there. All right, well, Amaranth's trying to get Barksteel squared away here. I'm just going to continue moving on here. What we've done is we were able to run linps on the host, and now we have this file called recon.txt. So very similar, if I go back into local mode by hitting Control-D, I can just say download temp recon.txt. And again, I don't have to set up an SMB share or some sort of FTP server or an NC pipe to copy files back. I literally can take advantage, if I type it right, I can take advantage of the framework to do the work for me. And now it's downloaded. So now if I jump over here, we can see that recon.txt. And if I was to do a --r recon.txt, we can see, oh, you guys will want that bigger. We can now see that linps output. I have it locally so I can review it. How many people here have never seen linps before? Everyone has seen linps? That's awesome. Bruce has never seen linps? Okay, well, no worries. Basically, it's an interrogation script that's going to check a whole bunch of things on the target and look for vulnerabilities. So as an example, when I scroll through this output, you'll see anything that's in red, yellow, like a gold color, that there's a 95% chance that that's a privilege escalation vector. If it's red, it's something you should be looking at. And if you see things that are in different colors, they have different meanings. So as an example, as I'm scrolling down here, even just for basic information, we can see that this account has sudo rights. As we scroll down, we can see that this particular machine is actually vulnerable to CVE 2021-4038-34, which is Homekit vulnerability. And we'll actually take a look at that in a little bit. But what's nice about what just happened here, I don't know if you've realized what we just did. We not only were able to upload a file, run it, we were able to download it all through Pwncat. There was no extra things we had to set up. It was all part of the framework. And that becomes very valuable to us because that allows us to be able to do a lot of the work in the system without having to set up lots of other things as we're going through it. Does that make sense? Okay. So what we're going to do now is not only can we use things to enumerate, we can actually do things to set persistence. So one of the nice things that we have to our advantage when we're on the system here is we can set up our own SSH keys. And if we have access on an account where we can do so, we can drop into the authorized keys, our local key that we can then leverage for persistence later, right? So we can have a backdoor key. So I'm just going to make one here.
Dana, just one sec. When you do upload, do you have tab completion? It doesn't work for me, but I'm not sure if it's my issue or not.
If you don't have access in temp, try dev SHM.
No. When you do upload, do you have tab completion for local files that you're trying to upload?
Yes. When so if I go /op tab.
Oh.
Tab.
Maybe it doesn't like tilde for the home directory. Oh yeah. Doesn't like tilde.
All right, so I'm just going to generate myself a temporary key here. Anyone know why I'm doing -C? Trick question.
Is that comment?
Yes. Why would I want to do a comment?
I don't know. So you know which key it is?
Nope. Here's one of the main reasons. If I was to, if you take a look at the end of your public key, whenever you generate it, by default, it's going to use your username and your host name in the file. Mm-hmm. And when you're doing an engagement, the last thing you want to do is provide evidence of where you came from or who you are. So it's a good idea to generate temp keys instead of using your own SSH keys so that you can leverage them. And that becomes useful in things like Pwncat because you can actually tell it, use special keys, and that'll allow us to do the work we need to. So in our case here, I'm going to say run implant list. And I'm going to do this to see if I have any implants on the system. And it's going to say right now, no installed implants. And that makes sense. We haven't done any yet. But if I was to go run implant, and you can tab complete, you can see there's 3 here: authorized key, PAM, and password. So authorized key is going to allow us to, in the current context of the account we're in, it's going to try to put our public key into the authorized key file. If we have PAM and you have permission, which you typically won't in the initial foothold, but at some point you might get root access or have access to write to PAM, then you would create a PAM module that would give you a default password that you can use to connect up with any account. Or thirdly, you could have password, which would just generate an actual username and password in the etc password file so that you can have a new account for persistence later. I'm going to use the authorized key because I'm going to use that to jump back and forth. So I'm going to say I want that. And for my key, I'm going to use that one I just generated called, what was it, temp key, I think. And watch what happens. So if I now go back into the account that I was in, into the .ssh directory, you can see there's an authorized key file there, and you'll notice that that's the key I had generated locally on my machine, which means it will now give me access to remote in via SSH. Well, not quite, and here's why. A lot of times nowadays, you'll actually find that the SSH directory is 777, and for the authorized keys to work in modern OpenSSH, what does that have to be set to? Anyone know?
700.
Yeah. So you need to set that. That's actually something I've actually asked Caleb to update in the module. It's because we should be checking for that and automatically doing that if we can. Now there's an argument about changing permission artifacts because that's something that might trigger an IDS. So that's a good argument to be made. But if we want to use the authorized key, we have to do that. But now that we've done that, if we go back into local mode and say run implant list, we can now see that their backdoor public key was added to the shell. So we track that in the database anytime we drop an implant in. And that's useful. So if we get disconnected, it's actually going to tell us, hey, you've left these artifacts on the machine. Did you mean to do that, right? And we can obviously delete them just as easily, right? So if we want to, so first I want to show you that the implant works. So if I was to go over here, and we did Pwncat CS shell at VM, and then -I temp key. We can now see I'm in. I didn't have to put any password in. My persistent backdoor is there. With me? Any questions so far? Okay, so we run that implant. You'll notice on this session, it doesn't show that an implant was there. And that's because it's only tracked in the current session as we're doing work. So it's not always a good idea to have multiple Pwncat sessions, but you can. It just means that you got to be careful to think about what's being recorded as part of the facts. Likes the emojis. Yeah, it's pretty cool. It's a really nice way of doing it. So we can obviously see here, we do have that implant there. And if I want to run implant remove, watch what happens. So if I remove the implant, it's going to say, okay, which one do you want? If you have multiple implants, you can select an individual one, or we could say all. And once you remove that, watch what happens. It removed it from there. In some cases, it may kill the session, the C2 channel, depending on what was used. But in this case here, it looks like I'm still good. Nope, it looks like it died. Because when it removed the implant, it removed the C2 channel, basically to drop it. So now this session is toast. Luckily, I still had this session over here if I need to. Okay, with me so far? So we've been able to upload files, we've downloaded files, we've been able to run some enumeration to run different kinds of commands, and we were able to do implants, dropping in an authorized key as an example. So this gives us lots of flexibility on the system. But we can do more than that. It's actually kind of fun because we can take advantage of these type of things for other scenarios. So first off, I'm just going to kill this session over here. And over on this side, I'm going to create a bind shell. So we've been showing reverse shells, but you could just as easily do a bind shell in here. And then you just do the same thing. Pwncat, and then it would be vm.hackme 4444. And now you can see we've connected up in another way. So now you've seen us do an SSH connection, a reverse shell, and a bind shell. So depending on how your flow is and how you're trying to get a remote connection, Pwncat's got you. And everything else works the same. So uploads and downloads and implants, it all work. You just got to remember that it's in the security context of whatever account you logged in as, right? So this one's logged in as shell right now. But if you were catching something like, let's say, a PHP reverse shell that came from Apache, that's probably going to be www data. So certain things like running implants for SSH isn't going to work because www data doesn't have access to SSH usually. But you get the idea. It all flows from here. But what if you want to be able to do more? So remember when we were looking over at the linpiece output, one of the things that it did was it was able to go and dump and tell us we're vulnerable to CVE 2021-40 604. That's called the Pwncat vulnerability. And what I'm going to do is I'm going to show you an example of how you can write your own modules to take advantage of it. So what I'm just going to do here is I'm just going to type over in this shell over here, info Pwncat. This is a custom, it would help if I'm in the local when I do that. What you can see is this is a module that will exploit automatically to prevent whatever account you're in to root. Now, if you've worked with this CV before, you know that there's a whole bunch of steps that you can do manually to do this. You basically create a whole bunch of directories, and you have to call system to execute pkexec in a certain way that's going to trip up the system, and then it'll cause you to get a root shell potentially. Or if you're using Pwncat, you can simply type run Pwncat, and it will automatically prevent you to root if the target obviously is vulnerable to that. And sure enough, we can see that my UID before was 1,000. Now it's 0. If I switch back into local mode, you'll now see I'm root. This is where Pwncat really has some very interesting powers. And this is where I want to take you next. So for those who have it in the workshop, there's a section there under, I'll just provide these URLs again. There is the workshop. And one of the things you'll see is a URL here, which is to a GitHub repo of the module that I wrote for Pwncat, for the Pwncat vulnerability. The pwncat.py is that file, and you can download that locally. And the way it works is if you drop a file into .local share Pwncat modules, it will automatically pick up that module, and you'll be able to load it and use it. In that repo I sent you there's also a sample. We're going to use that in a little bit because we're actually going to go and write our own. But let me just quickly run you through what a module looks like. Hey, Amaran, can you see the text on that, or do you need that bigger?
I'm good. I was just translating somebody else's request.
Okay. All right. So a Homekit module really comes from, it's a Python script that is based out of the Pwncat modules. So if you import the base module, you can build out your own modules. In our case here, there's some configuration we have to do. We need to tell it what platform we support. So we've been showing Pwncat working for shells on Linux, but it also works on Windows as well. But in our case here, this module is Pwncat, which is targeted to the Linux kernel and pkexec. There's some arguments you could add if you wanted to, but you'll notice I typed run Pwncat, no extra arguments. So I don't have any args here. So at the beginning when it ran, you notice it said preparing to prevent to root. That's just a command called status. So all of that pretty graphical view you get with color coding with ncurses, that's all taken care of for you via the status. So when it was running, although you don't see it here now because it runs it as it's executing, that gets written out using the status object. Now, the actual exploit doesn't really matter, so I'm not going to go too deep into here, but for those who are curious of what it does, basically here's some source code that's here that basically just sets UID, group ID, effective user ID, and effective group ID to 0 or to the root user. And then it does some magic with this gconv path as part of the exploitation. And when you run, you'll see there's a wrapper here, the shell. When you run pkexec with a null payload into an environment, with the environment set to the stuff we were just talking about over there, this actually will exploit the policy kit in Linux and get you a root shell. So all I did is I wrapped it up into a variable. And what's cool about that is that I can then, I'm just going to scroll down here to a little place here where we do, I'll highlight this here. the framework has the power to do compiling. Now, what I mean by compiling is if the remote host has the right targeted tools like GCC, it will compile it on the remote host. However, if you set up cross-architectural compiling, in other words, you install GCC locally with the multi-arch support, it's actually smart enough to take a look and determine the remote architecture and compile the binary locally on your host with all the proper libraries, and then it will upload it to the target. So if you've got an ARM-based target, but you're running x86, it doesn't matter. As long as your GCC can actually compile and target the remote in there. And this becomes very powerful because a lot of times in a production target, they're not going to have GCC installed. So most times when you get exploits that you want to run, you can't. You have to build it locally. Well, what if you're not of the same architecture type? Well, that's what Pwncat can do for you, is it actually has the capability of actually compiling what's there. So in this case here, the stuff that we had up here, this source is actually getting compiled. And so what you can see here as we're going through here is I'm generating a random seed. I just want something random because I don't want an intrusion detection sensor to note that this is a normal Pwncat exploit, since things like Snort already know to look for certain patterns like this attack. So by generating a random path for this and random names, and in my case, throwing it in dev SHM, I can do this exploit and it's random and different every single time. So it's not as easy to find. So it's not that it can't be found, it's just a little harder. And then you can see anytime you have the session.platform, these are basically just Python calls, and you can look into the Pwncat API docs to figure out how to do common things like creating paths, making directories, touching files, writing text out to files. This is all capable through the Homekit module, and it will use that C2 channel to execute these commands on the target host. So in this case here, we compile our exploit. We also compile the wrapper for the exploit, and then we trigger it off. So in our case here, we do what's a popen, because that C2 channel is nothing more than a pipe. So we can basically open that pipe. We can redirect standard in, standard out, and standard error to the pipe, run the exploit, and we'll be able to get all the information we need and collect it. So in our case here, after we're done with it, we detach from the channel so that the system can continue to work. And we can then check. We can check our UID and see if it changed. So what you saw when we ran that is you saw that the UID before was 1,000 and after it was 0. So we know it was successful. And then at that point, that's it. We check it and we then clean up. So in our case here, I want to remove all the artifacts. So I actually check to see if any of those artifacts still exist on the target system. It did. Unlink it or delete it so that we don't leave any evidence that the exploit ran. And we're done. Can you control limit the CPU during the compile to avoid potential detection? Well, remember, if you've set up cross compiling, it will compile on your host locally. So all compute is done on your own machine. If you decided that you wanted to popen or run GCC on the remote target, then it'll be a standard compile. What a normal GCC operation is, that's what would happen on the remote host. I highly recommend, if you can, compile it and run it all locally. So the artifacts and everything that's done is done on your machine, and then it just uploads the binary, in this case here, to the scratch path to a file called exploit. And I probably could have randomized that, so it would have been even harder to detect. And that's it. That's all a module is. It doesn't have to be much harder than that. But it's kind of cool because you get the flexibility now to use this C2 channel to write automation code to do anything. So once you do that popen, you're in a good state because you have a pipe to that remote host and you can do anything you want in there. Now, if you go take a look at Pwncat read the docs, I'm just going to Pwncat docs here. At pwncat.readthedocs.io. All of this information, if you want to write your own, it sits there under the API documentation. You can even just write your own Python scripts, use Pwncat without actually having a shell. It can create the connection for you and do all the stuff we're doing by hand. You can automate the entire process if you want to. But I like going into the manager and the sub-process modules and leveraging what they've got there, because that's where a lot of this capability exists, where you can do all of this meat. With me so far? How many people here actually have Python foo? Wow, not a lot of you. Python definitely is the best. You were right. But as you saw there, just how clean that was. If you download that pwncat.py file that's in my repo and put that in user in .local share Pwncat modules, you will, next time you run Pwncat, it will automatically be there. And anytime you connect to any host, you can just type run Pwncat. And if that remote host is vulnerable to that, you're root instantly. I also have one called Dirty Pipe. So if you go look in my in my GitHub, you can get the Dirty Pipe one as well. I have a few modules I've written just to make life easier for escalation when we're doing that kind of stuff. Any questions so far? Okay, so we're about an hour into this now, and what I want to do is make sure that everyone has the ability to get Pwncat running, connecting with a shell, and then we're going to load up a custom a sample module just to make sure that you understand how to work with these. So if you are not currently able to get onto a VM on TryHackMe and you want to, can you just call it out right now in the chat? And if you are in the chat, if you are on TryHackMe's network and you have a shell with Pwncat, can you just call it out? Let me know you got it. Woo -woo. Awesome. All shelled. Nice. Okay. So for those of you with shell, there's a bunch of you. So Bill, are you trying to get one set up right now? Or are you just watching? We'll get you sorted out if you want to. All right, so for the rest of you that got shell, if you go to the Pwncat workshop and either download that sample.py file, so there is a Python file that looks like this. Very rough, raw, does nothing. It's just called sample.py. Don't have a VM or Kali Linux to try. Oh, okay. Well, if you don't have it, no worries. Just sit and watch. For those who have it, though, download the sample.py, and I want you to drop it into any directory. Doesn't matter where.
I missed that, Dana. Is sample from the Pwncat docs?
No, from the workshop. So,
oh, okay, okay.
In that, there should be a sample.py file. So whatever directory you have that in, here's an interesting command that you have at your disposal. So I'm just going to hit Control D to go back to local mode. And you can type load. And what load will do is it will load a directory of modules. So in my case, I have mine in home, Silverster, work, Pwncat, workshop. And if I now do info sample, you'll see that the sample custom module loaded. And guess what? If I typed run sample, it ran. It did nothing, but it ran. This is the start of your custom module journey. Because with this, you have everything you need to start writing code to be able to automate things that you want to do on the remote host, right? So if we go back, and we do a search here, you can see things like the Pwncat commands and the module for session.run. These are all commands that you have the capability of being able to do things with. So as an example, if we go back and take a look at that Homekit module I wrote, you can see some of the basic commands I was doing, like checking if there's a directory and using the session.current_user to get the current user's ID. We can use these things to do interesting things, but the one that's probably the most interesting is if you start working with the platform popen or the platform.run. So if we were to go to platform.
Dan, a quick question.
Yeah.
So I had an active Pwncat session, and then I dropped the module file into that .local/share whatever Pwncat modules.
Yeah.
And the Pwncat doesn't see it. So
you,
it's not dynamically loading the modules sort of there, or do I need to do load?
Yeah, you have to do a load on the directory.
Okay. Even if I dropped it in the default directory?
Yeah, it doesn't dynamically see it after you drop it in. If you want to have it load up for you automatically without calling load, you can do that if you put it in the .local/share Pwncat directory. So if I was to, now I knew I was going to actually be showing this, so I removed all my work, but
that's what I did.
Yeah, the problem is that will only load when you load Pwncat. So you can't dynamically load that. That happens when you just call Pwncat and get connected. It'll load everything there. So if you build something and you use it on a regular basis, that's a great place to put it because it will automatically load. But in cases where you don't have that or don't want that, then you can just put it in a different directory and then call load. Caleb has actually got a pull request right now to dynamically reload once directory is there. So modules won't need to be manually reloaded each time you make a change. And that's one of the things you need to think about. When you're making coding changes, you'll have to reload the module because it has to reload it into memory. Okay, so good call. Thank you, Kevin. Make sure that you go in. I think it's 2 hours, so it shouldn't be too bad. But if you think you're running out of time, add an hour. I can't because it hasn't been an hour yet. So, but how many people have been able to get the sample loaded? Awesome. All right. So now the world's your oyster. You now have a Python script that can auto load into Pwncat to be able to do anything you want to. I'm not going to teach you how to write code here. That's not the intention of what we're doing here. But if you take a look at like the Pwncat platform docs, I'm going to paste this into the chat as well. You can take a look at all the different commands that you can run. And everything from being able to remove directories and touch files to basically create them, to write text or bytes out, these are all there for you. So you can take a look and decide what you want to be able to do. I've given you a link to the Pwncat module that I wrote, so you can look at how to do things like do compiles, how to create directories, touch files, how to upload content, how to remove content. Those are all examples that you can use on there. And I encourage you to check it out and give it a try. Because at this point, anything you can write in a Python script and leverage through the Pwncat platform tools, you have the capabilities of being able to affect change on a target automatically. And that gives you some very interesting power. Any questions? I like Bill's question there. That's one of the great things about things like Try Hack Me, because you're creating a private VPN connection to a network that's in your control with VMs that you can destroy. You can detonate whatever you want there, and there's not a lot of risk. However, if you're doing shared networks, which are different, those networks are shared with other people. And so there is some risk, which is why you should make sure you've hardened your VM. So I'm in a VM right now. This is my dedicated Try Hack Me VM, not my work VM, so that I can do stuff on Try Hack Me and not care. But if that's a concern for you, that's one of the reasons that you want to have a VM and use things like OpenVPN, or you can use the attack box that Try Hack Me offers you. It's just you don't have as much control over it to be able to affect change on tooling and whatnot to get to keep it. Okay. All right. So any questions on what you've seen so far in Pwncat? Okay. All right. So who has generated their own SSH keys and have now implanted an authorized key backdoor? Anybody? Awesome. Good job, Jason. So for those who weren't sure how we did that, let me show you. I'm going to, first thing I'm going to do is I'm going to run implant list. Did we remove the SSH one on there?
Maybe just the wrong session.
Yeah.
Oh yeah, you did
also
remove
ready
it.
root. Yeah, so there's none in there. All right, so over here, so you can see I'm in a weird state now. There we go. So you can start by just doing SSH keygen. Then you can create a file, I'll call it test, and use a comment, something, I don't care what you do, grr. That's going to generate a key pair for you, right? So we can see we have a private key and a public key. This is something you probably do on somewhat regular basis when creating your different keys. Now all we're going to do is we're going to copy that test.pub key into the authorized keys file. Now I could just open this file or echo it and do all that stuff. That's all a way to do it, but it's easy to wreck that. If you don't have proper TTY, maybe your editor's not working quite right, you can make mistakes, and why worry about it if you can automatically have Pwncat do it for you. So if we go back into local mode, we say run implant dot, can't remember what it's called, hit tab, there it is, authorized key, space, key equals, and then the name of the key, which I think I called test that time. And what it's doing is it's running that module. It is doing the work it needs to, which is to basically transfer that pub file using the upload command into that channel. It's going to then open up the authorized key file and append it to whatever is there. So now if I go back into remote mode, we can see my key is there now. Why is that important? Because now at any time, I can just SSH to shell using that key, and I'm in. No password needed. Or I can use Pwncat and accomplish the same thing. You with me? Well, that's really it about how Pwncat works. It's the C2 framework that gives you the flexibility to hook in and run your own commands if you want to, using this base module, which I've shown you the sample. So if you know Python, you can now, where I have added do your work here, you can write your own module to do whatever you want it to do. So using the docs that I pointed you to, how do you disconnect from OpenVPN? Control C. So that's all there is to it, is you give yourself the ability to run those commands. Now, by the way, when we're looking at the enumerate stuff that we were talking about, take a look at what's there. There's a lot of different things that you can check out. And these all have value depending on the kind of work you're trying to do. So if you just wanted to say, as an example, get all the processes in the system, enumerate.system.process, it's very nice to have that stuff automatically get collected for you and then stored back so you have access to it. Of course, you could just as easily call PS, AUX, et cetera, to get the same data. But by doing it through these modules, you get the benefit of it going through the C2 channel. And so that gives you A, information that you can keep in your report, and B, it gives you the ability to collect all that information without doing a lot of work. But once you're at a point where maybe the modules aren't enough, you can use the upload command to easily upload your own scripts that you have, even when there's not a normal way to upload, and you don't have to set up a web server or an SMB share or some other way to transfer files, because you can use the C2 channel to accomplish that upload. Again, it does it because it looks for any kind of write primitive through GTFO bins. So it's basically looking for any vulnerable way that a write can occur, and it will leverage that to do the upload. And then of course, in the download, it's just reversing that. It's looking for ways to read files and then bring that stuff back. So as long as you have permission to do that in some way, it will use that to then download that content back to your local host so that you then have direct access to it. I also showed you how to do this through an SSH connection, a bind connection, and a reverse shell, which means if you have to ever catch and work with a shell, there is no reason why you can't use Pwncat to do that. With a caveat, Pwncat's not the best when trying to catch Windows shells. I find it to be hit and miss. It really is dependent on how you created that shell when it's called back. Sometimes it's a little flaky. I'd rather use a interpreter shell in those scenarios, simply because it's just more robust. But to each your own. I hope you'll try this out the next time you want to. One of the things I didn't show you here, because I knew it'd be just a little complex on there, whenever you're catching shells, one of the issues is normal Netcat shells are easy to detect because they're not encrypted. However, Pwncat supports the ability of using SSL connections. So it is possible, if you generate the certs and do the work you need to do, that it is possible to actually generate secured Pwncat shells. And you can check out their docs on how to do that if you want to do that. But there you go. That's how to work with Pwncat to be able to have better, more stable shells. Any questions? How many people here have used Pwncat before? Yeah, you absolutely can use it in real life pen test engagements, Kevin. Actually, I use it all the time. It's my preferred tool. I can't show you some of my work modules, but I have a whole bunch of modules that I use specifically to do a lot of collection and exploitation, specifically for this reason. Yeah, it is a very cool tool. I think the biggest thing, if you're new to catching shells, the biggest thing that Pwncat will do for you very well is the stabilizing of the shell. Because you'll notice when we were catching those shells, not once did we ever have to do a Python -c, import PTY, blah, 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 then STTY and change all that. That's all taken care of for you. And that in itself is more than enough. And it's that aspect of, hey, if I accidentally hit Control-C, I don't lose my shell, which happens a lot when you're running around doing stuff and you don't have a very stable shell. Plus things like having history and up arrow and back arrow. These are all very nice luxuries to be able to have through Pwncat. All right, Airman, I don't see any more questions coming in through the system.
Any other useful modules that's worth paying attention to?
So here's the thing, whenever you want to know, just type run space and start hitting tab, and guess what? There's a whole bunch of different ones you can take a look at through there. The enumerate is the main one, implant is the secondary one, and then you have the reporting, which gives you the capability of running reports. And by the way, I was showing, by default, reports are written out as markdown files, but you can use a parameter to write them out as HTML if you like. So for people who prefer HTML reporting, that's a capability as well when generating your reports. Also take a look on GitHub. Lots of people like me write and release different modules. Some of them get merged into the system. There was about 6 months ago, 7 months ago, Caleb kind of rewrote a bunch of it to make it more Metasploit friendly, like, you know, how we use the commands and tab completion and everything. Before that, there was a bunch of other things like auto escalate, where it would actually have capabilities to, you detect what user you want, and it would actually go through and give you a path to auto privesc if it can into the system. But a lot of those capabilities broke when they redid some of the modules, and some of the modules like the PAM module are somewhat flaky right now, and they're working on it. It's an active project. You're welcome to add to it if you want to, and it's pretty good that way because you get all the community contribution on top of that. This is way better than a standard Netcat shell, but it can always be improved.
All right. Any other questions?
Why don't we just open up the chat and anyone can just talk if they want to.
Yeah, sounds good. Mute. There we go. So everybody, you can now, if you want, you can unmute yourself. If you've got questions, comments, just, you know, interesting topics, if you want to present. We're going to have another workshop in July with Kevin, who's here today as well. And we're going to be doing, likely going to be doing lightning talks in August, kind of the Hacker Summer Camp follow-up. So if you've got some favorite talks you've seen at Black Hat, DefCon, besides Las Vegas, or any other conferences you want to sort of cover in 5-10 minutes, let us know and we'll slot you in. Hey, Jason.
Hey, I'm good to see you.
How are things?
Things are really good. I just haven't been able to attend DC604 in a while because every last Thursday I'm busy in the evening, so it was good to attend this one.
Right.
Cameron, you might want to turn off the recording.
right. Stop recording. There we go.